Hey, we're going to be talking about continuity and continuity at a point. And so I've kind of sketched up a graph here just to get an idea of what we're talking about when we talk about continuity at a point before we actually get into the actual using limits and some particular steps that we got to find if a function is continuous at a point. Well, as you can see here, I've got like a piecewise defined function. At -6 here, the graph is not continuous. You can see that it's broken, so it's not continuous at -6. It's also not continuous at -2. There's we can consider a vertical asymptote here at -2. It's not continuous at 2 because the graph is broken. Here it's not continuous. There's a missing point in the graph, so that's not continuous. But what about here at 6? Now this black dot here just represents a point on the graph, whereas the white dot represents there's actually a missing point there in the graph. Well, it's continuous here at 6. So if you want to imagine this like being a road and you're traveling along the road and you want to get from, let's say, here to over here, well, we can't do it because this is going down to -infinity as x gets closer and closer to -2 from the left. But as you can see here, if we were somehow able to get on this road, we can travel along, so we have a nice smooth road, and then all of a sudden there's a dead end, so you can see it's not continuous between or at x equals 2. Now let's actually look at the steps that you need to take in order to determine this. So this is kind of what we follow here. Now there's no really particular order, but we want to at least try to follow we're going to follow this order that I've got laid out. Alright, so remember at -6 the graph was broken. And so what you want to do is you want to look at the left-hand limit, that's this negative sign here coming in from the left of some function f of x, which is being represented by our graph. Well, that limit was equal to 4. And then coming in from the right-hand side at -6, it was 6. Well, both of these are not equal. Therefore, the limit doesn't exist. And if the limit doesn't exist at -6, then that means it's definitely not continuous. But let's go ahead and see what the next step would be. We would plug -6 actually into the function, and it turns out that it's actually -2. Let's look at the graph. Okay, so here was -6, and we were plugging -6 into the function. Well, we can't use either one of these points here because these are open circles, means it's not defined at -6. So we'd have to go down here and look at this black dot and its corresponding y value, which I don't have labeled on the x-axis, but I do think we already talked about it. But so as you can see at -6, right, it's this corresponding y value here, which happened to be -2. And then you would do that for some of these others. Let's just kind of scroll down through here, see what we got. So we were looking here at -2. And you can see -infinity, which aren't real numbers, therefore the limit doesn't exist. This is undefined. Okay. We've got the next one down here. Right. Doesn't exist. Let's look at one that actually does exist. Okay, at 6 here, the limit coming in from left is -2, coming in from the right it's -2, therefore the limit of f of x approaches 6 is -2. And then we looked at f of 6, which happens to be -2. Now since this is equal to the limit of f of x approaches -6, since they're both equal, then we can finally say that we found one of these where the function is actually continuous at the point, and that happens to be on the x-axis 6, and its corresponding y value is -2.